Hi everyone. I thought I'd introduce you to a little shortcut for collecting like terms to solve equations. I've created two methods here to do the same question. You can see it's the same question on the left-hand side as what we're going to do on the right-hand side. I just want to show you the traditional way, method one, the way that we would do solving equations by collecting like terms based on what we learned in the previous lesson. So in the previous lesson, we learned that we'd have to do the inverse operations to both sides. So for instance, if I have 4x plus 3 equals 6x minus 9, and I want to get the 4x, or the x's, to be by itself, I would want to get rid of this plus 3. And to do that, I would have to subtract 3 from both sides. In my next line, I would know that some zero pairs got created here because plus 3 minus 3 would just be 0, so there's no need to write that. I can just summarize it with 4x. On the other side, I could collect the like terms together in terms of this negative 9 and the negative 3. That's going to give me the negative 12. Okay, so from there, I'm going to look and see, well, I've almost got the x by itself. The problem at this point is we have this 6x on this side of the equal sign, and it needs to go to the other side to be with the 4x. So to get rid of the 6x from this side, I would subtract 6x. And if I do it to one side, I have to do it to the other side as well. What that does for me is it lets me collect the like terms on the left-hand side. So 4x take away 6x is going to give us the negative 2x on the left-hand side. And on the right-hand side, that 6x and the negative 6x again have created a zero pair, so I can just cross those out and know that it would be equivalent to a 0. That leaves us with negative 12 on the right-hand side, and I have negative 2x left on the left-hand side, and at this point I can divide both sides by the coefficient of x, which is negative 2. So I'll divide both sides by negative 2, and that will let me wind up with the answer of negative 12 divided by negative 2 is going to give me a positive 6. So x is equal to positive 6. So that's how we would do it traditionally if we were going to show the creation of zero pairs. The second method is going to show you a little bit of a shortcut. So to do this shortcut, I'm going to make a little bit of an analogy here, and I'm going to imagine that an equation is made up of two houses, a house that is on the left-hand side and a house that is on the right-hand side. So in this analogy, we want to get all of the x's living in one house. We want to get all of the numbers living in the other house. And it doesn't matter which house you decide to put the x's in and which house you decide to put the constants in. As long as they wind up together on their appropriate sides in the same houses, you're good. So for our purposes, what I'm going to do is I'm going to keep the 4x living in the left-hand house. So here's the house, the 4x remains living in that house. Looking over at the right-hand house, I can see that there is the 6x that needs to come over and live with the 4x. It needs to move houses. So just like if you were ever going to move houses, in your move you would have to change your address. So this 6x living in this house is a positive, but if it moves across into the other house, it's going to have to change its address into a negative. So basically what we've shown here is that if a term moves from one side of the equation to another side, it has to change its sign. So looking at the right-hand house, we know that that negative 9 is going to stay in this house. It's already a constant by itself. We just want to find the other constant that needs to move with it. In looking at the original equation, we can see that there's this plus 3 living with the x's in the original line, and it can't be there anymore once we start moving houses. It's going to have to move across the equal sign into the other house. So since it's a positive address when it lives here, as that term crosses the equal sign, it's going to become a negative address, or a negative 3. So now that we've got everybody living in the proper house, our final steps are just to simplify or kind of clean up each house. So if we look at this 4x minus 6x, we're going to get negative 2x. That's kind of how that house will clean up. In the other house, we have this negative 3 and this negative 9. That's going to clean up to be negative 12. Now, like you know from our previous example, when we have a negative 2 in front of the x, we're going to divide both sides by that coefficient. And look at what happens here. We wind up having negative 2x divided by negative 2 is just going to give us x. And negative 12 divided by negative 2 will give us positive 6. And we can see that that matches with our answer from method number 1. So what we've proven here is that we can use this shortcut of not having to write the 0 pairs. All you're going to need to do is move a term from one side of the equal sign to the other side, and whenever a term crosses that equal sign, it will have to change its sign. I hope that helps.